Of course, it's any other Tuesday. Drop a Marshall JCM 800 lead series amplifier right there on my bench. Because why not? Let's get started. And because Marshalls hate me, they have to put all their screws on the bottom, because that would make it very difficult to get under here. Hey, look at this. Are you sure all he wants is like rebias?
Yeah.
Look at these capacitors. They're like from the Stone Age.
Yeah.
Jesus Christ. There's no hum in this thing?
No.
Oh,
Shouldn't be once it's biased up and ready to go again.
Bless his heart. Okay. Well, we'll get started then. There's a great deal of satisfaction in pulling the amp out of the case and saying there's a lot less to work with. Look, take a look at the signatures of the folks who built this amp way back in yesteryear right there. That's quality control. I think that's kind of cool. All original, kind of crusty, but all original. And I am not here to change any of that except for what I'm here to do. So let's do what I do. What joy and beauty to cherish forever. Look at this. This is unmolested, original, very nice. I like stuff like that. Look at that. Look how they bent the wire here. Like everything here was just done nice and clean, you know. This is not an ancient amp. It's just it's a vintage amp, you know. I like it. Okay. First, we're just going to take a quick look at the electrolytics. As a matter of fact, I'm actually going to use a camera for this just to see if they're bloated. And they're not. I'm going to measure them right quick for him. An ESR, they are still within specification. I wish they were a little lower, but they are well within spec. I'm going to let them go, say that they're good. We got some filtration down here. I'm also tempted to take a quick look at just because this amp is awesome. Both these read 50 nice. This one's tied together, reads about 95. This one's reading a little lower than I would want it to. Not terribly low, but enough that I would tell the owner, hey, you may want to start looking at the possibility of new electrolytic capacitors in the near future, right? I don't want to cause any alarms, but yeah, reading 80 on a 50 by 2 is a little bit low for my liking. We're going to be pulling out these bad boys and replacing them with some new tubes. So I've cleaned these 3 sockets and replaced the 12AX7s. There's only one shield, so only one will get a shield back on it. And now the EL34s. Look at this match set. Very nice. There we go. We got the EL34s in. And I have got my inline current meter all set up. This was an old tube, by the way. But yeah, rare does it happen that I drop one. But in case you ever wondered, there you go. So I just fired up the amp now. I still got it on standby. I would like to know what the plate voltage is. And just turning it on right out the gates, I'm seeing 38 milliamps, and that's not alarming, right? That's a number that I can work with just starting things up here. So I'm not like screaming, right? So let me start probing this, because if we're seeing current, right, then I could at least derive a plate voltage of 467.
So 38 would be about right.
467, 466 on 38.2 milliamps.
So they're doing 33 to 32 for average on hot side 39, 37. So tone it down a skosh. It'll be alright.
You want it down a scooch?
Yeah.
Okay, so what do you want? You want like 36 milliamps?
36 would be sweet.
Okay, stand by. So having derived those values now, I'm just going to show up here, right? And it is a little bit subjective, right? So this has to do with a little bit with opinion, right? But we can see a little bit of variation here. This pot's seen better days, but I'm just being real nice to it. Real nice to it right now. And we got a nice 36 milliamps, right? And by the way, I'll point out that all the tubes are tied to this bias, right? What I'd like to do now is let this amp cook for about 5 to 10 minutes. This is going to change because the tubes are all brand new. It's just what it is. Characteristics are going to change. So we're going to come back.
7 would be exactly 70%. So yeah, that's good.
Okay, like I said, we'll let it stabilize.
Yeah.
This amp is in pristine condition. I have recommended that the electrolytic capacitor on the bottom here be replaced if they so choose after, what is this now, 30 something years old?
Yeah, 31.
Yeah, if you wanted to go for gold and replace all three of them, I'm the kind of guy who really doesn't care. Just get rid of them because I hate electrolytic capacitors. Replace them all. But if you could only replace one, it'd be this one, right? That said, both of these measured well for ESR, but the bottom one, oh, I've destroyed focus. The bottom one is just within specification, right? So I would recommend these two get replaced because it costs next to nothing. This one must be replaced, and I would just replace the rest with it. I would touch nothing else on this amp because this is beautiful, right? And things are working really nicely, and it is starting to stabilize. We could see that it's still changing, it's still moving, and that's just fine. So we've been sitting here a while, and we have already made some adjustments here to the bias, bringing it back to 36 as the tubes burn in. It's starting to stabilize now. It had run a couple of milliamps off of our original number as expected, but things are looking good now. You could see that given some time here, this is now at 36.6, and one of my concerns is that I'm testing one tube and assuming that we're trying to keep it at 36. It says it's a match set, but I never trust that stuff. I have to hook my test set up to each and every tube and find out what the current flow of the highest tube is, right? So if this is 36.6, 36.7 and climbing, is it possible there's a tube here at 37 point something? We don't know. So right now I have to drop this back down to 36. There we go. I've got it back down to 36. But I'm going to need to go through the other tubes and have a look and see where they are. Point out something as a segue to my next conversation here. We can see this orange and green cables coming off here. Orange makes its way down this way, green comes up this way to the EL34s. This is the negative bias, right? And I'll tell you right now that I have gone through all four tubes, and the negative bias is exactly the same on all four of these. I'll further point out that the 468 volts of plate voltage is consistent across all four EL34s, and it stands to reason because it is daisy chained. The back yellow wire we could see here is providing that. So when I look at the box that the tubes came in, I hear all about Robotube automatic computer tube testificator that does all this wonderful tube matching stuff with these tube testing reports and what have you to guarantee that the tubes that I got are exactly the same to specification. I wonder how I have a difference of 6 milliamps between the lowest and highest tube and none of them match, right? And I'm being kind on the 32 because it's like 31.9, but I'm like, whatever, it's 32. So the first thing I want to do, right, to rule out the amp, and I pointed out just before, biases are identical, plate voltage is identical, but due diligence says that I should take the tube in the lowest socket and the tube in the highest socket and swap them and see if the change follows the tube to say it's the tube or the amp. So I'm going to do that. So the tube that read 30 milliamps up here and the tube that read 36 have now been swapped, and the 30 milliamp reading tube is now in the 36 socket, and I am firing it back up. It is just heating up now. Yeah, we can see that the 30 milliamps is clearly following the tube, and there's nothing wrong with this amp. There's nothing I would change on it. It's worth mentioning, though, that had I used this tube as a reference for 36 milliamps, I would have dropped the highest tube into 42 milliamps, which has been an excessive amount of current for an EL34 for this application. So I am not impressed with this tube matching. Not very happy with it. I would have liked the old-fashioned way, which would be like have a bunch of them and stick them in the amp and get them all to match. But I wasn't afforded this luxury. This was just the tubes that I was given to do this job. But that being said, also in fairness to the amplifier, there's only one bias control for all four, right? So if you wanted all four to have the same current flow at a given plate voltage, they would have to be absolutely perfect to each other. And the amp doesn't care about that because it's not like a Macintosh or a Dynaco. It's not a hi-fi amp. It's a guitar amp. So it's absolutely okay that they're off. I'm just, for the purpose of biasing these things, you have to know which is the highest and lowest tube to do this. You have to bias with the tube that is already reading the most current flow, because if you bias with the one that's reading the least current flow, you're going to have problems. So that's it for that. We're going to slap it back in the case now. I hope you all enjoyed the Marshall JCM 800 rebias video. Thanks for watching.